Hello folks, this is Mr. McAllen, and today we're going to talk about trigonometry values for special right triangles. These values are very important because on a college entrance exam, when they're trying to test, the colleges are trying to test you for knowledge of trig ratios. Without a calculator, they would expect you to know how to handle 30, 45, or 60-degree angles. So students should be able to find all 6 trig ratios after today's lesson for a 30, 45, or 60-degree angle, as long as you remember your reference triangles. And you should be able to determine, if I give you the ratio, what the angle was as an objective 2. So let's first start out. It all is based upon your knowledge or ability to remember what sides go where with a 30, 60, 90 triangle and a 45, 45, 90 triangle. So I'm just going to draw in the angles so that we can see what they are. Now, on any reference sheet given to you on the SAT, they would give you this information. But for pre-calculus or algebra 2, we would expect you to remember this type of information. So the sides on those reference sheets opposite the 30-degree angle is the smallest side. They would label that with an X. They would label the side opposite the 60 with X root 3, and they would label the third side, or the side opposite the hypotenuse, opposite the 90, as being 2x. On the 45, 45, 90, they would label the sides to be S, S, and S root 2, because what they're going with is they're saying that, if you had a square, the side length would be S, and the diagonal would have a length of S root 2. With this information in mind, you can also draw a little reference triangle to help you out as well. If you're just trying to do the trig ratios, and you can just say that x is equal to 1 for both, for all the x's in this picture, and you would know that the shortest side you could say is 1, the middle side is root 3, and the longest side is equal to 2. This will help you figure out your sine, cosine, tangent for 30 or for 60. And for the 45, 45, 90, you can just remember or memorize the sides to be 1, 1, and square root of 2 if you let s equal 1. So here's your 45 and your 45. Now with this information, you should be able to answer questions about what the sine, cosine, tangent are for various angles. So as an example, I have 6 here, and we're going to do, we'll do the sine, let's do the cosecant, and we'll do the cotangent, and then I expect you to pause the video and then write in your answers for the other 3 after. So for the sine, since the angle is 60, we're going to look at, because sine is opposite over hypotenuse. We're going to look at the opposite side for a 60 is root 3, and the hypotenuse is 2. So my sine ratio for 60 would be equal to root 3 over 2. When I get to cosecant, I have to first remember that the sine of theta is equal to 1 over cosecant of theta. So when I'm trying to do cosecant of 30, I first have to do the sine of 30, which I'll do with this picture. And when we're working with the sine of 30, I'm going to circle 30, and my opposite side will be 1, and my hypotenuse would be 2. And that would force the cosecant to be the reciprocal. And you can just write that as 2, not 2 over 1. Last one, let's look at the cotangent of 60. Well, first, cotangent is a reciprocal of 60. So first, let's find the tangent of 60. So I'm just going to erase those circled angles. This was 30, this was 60. So the tangent of 60 is opposite over adjacent. So I would have for tangent root 3 over 1. And then for cotangent, I would just do the reciprocal. And remember, you have to rationalize that, so you would end up getting root 3 over 3 for your exact answer. So your final answer for cotangent of 60 degrees would be root 3 over 3. That being said, I'd like you to pause the video and figure out the cosine, the tangent, and the sine of 45. Okay, so we're going to be working with this triangle for the second part, and I'd like you to try that, and then when you come back from the pause, I'll have the answers filled in. So please pause your video now and give that a shot. Okay, we're back, and now we're looking at those answers. So you can see the cosine of 45 is 1 over root 2. That should be rationalized to give you root 2 over 2. The tangent was equal to 1 over 1 because the opposite over the adjacent of the 45-degree angle was 1 on 1. And the sine is also equal to root 2 over 2 once you rationalize that. So now we move along to our second objective. What if I gave you the ratio and asked you what angle would give you the ratio? So let's just speed ahead here to those types of questions. So these questions are phrased. If you know, if you're given a ratio and you say like the sine of theta equals root 3 over 2, can you find theta? Well, this again comes back to those reference triangles. So we draw, if you know you're going to be working without a calculator, you know the only angles they can really be asking you are 30, 60, or 45. So put in your sides, you have 1, root 3, and 2. And then here you have 1, 1, and root 2. So when we look at the first one, we think of, well, the opposite side is root 3, and the hypotenuse is 2. So when we look at the triangle, if the opposite is root 3 and the hypotenuse is 2, it's got to be that angle 60 degrees. So this would be theta is equal to 60 degrees. Let's do the next one. The cosine of theta is equal to 1/2. So if you write down the cosine of theta is equal to 1/2, cosine deals with adjacent over hypotenuse, just from SOHCAHTOA. So the adjacent would be 1, and the hypotenuse would be 2. So when you look at your triangle, if 60 degrees is the angle, adjacent would be the one side, and 2 would be the hypotenuse. So theta, in this case, must be 60. So theta would equal 60 degrees. The last one is, let's try cosecant is 2 over 1. So if cosecant of theta is equal to 2 over 1, then you have to change that to sine first because they're reciprocals as being 1 over 2. And then you look for the angle that has an opposite side of 1 and a hypotenuse of 2. So in this case, 1 being the opposite, 1 is opposite the 30. Let me clean up this picture for a moment. So we'll just draw the triangle back in, and 1 is opposite the 30, 2 is the hypotenuse, so theta must equal 30 degrees. I want you to pause the video and answer, here, let me just write this down, theta equals 30 degrees, and I want you to answer these two questions using the diagrams shown below. So I'm just going to pause the video, and by the time you come back from the pause, I'll have the answers done. Okay, well, we're back, and the answers are theta must be 60 degrees, and if we explain this, the tangent of theta equals root 3, which you put root 3 over 1, and now you know what the opposite and the adjacent must be. So if the opposite side is root 3, then the angle must be 60. In the next question, we have the sine of theta equals root 2 over 2, which tells us that the opposite side must be root 2 and the hypotenuse must be 2. But what we have in this triangle is not written like that. So what we have to do is we have to simplify this ratio so that, or at least recognize that this is root 2 over 2 that's been rationalized. And if we go backwards, we should notice that that's the same ratio as 1 over root 2. And then, so that would mean that the top component is the opposite side. So the 1 would be opposite. The root 2 would be the hypotenuse. And that would give you the reference angle of 45 degrees. Hopefully this video has helped you, and tomorrow we'll do lots of practice in class on problems that require us to do trig ratios with 30, 45, and 60. Thank you, and goodbye.